Okay, but why?
Hi everyone, and welcome to today's episode of Okay, but Why? Now, the last time we finally got to embark on our exciting adventure to get to see these tiny atoms and molecules. And I told you that it's going to be completely different from the way you would normally see things in this world. For starters, if I wanted to take a picture of a molecule, then the first thing I would need to do is turn the lights off. Yep, that's right. And if you think that's strange, then let me warn you that we are only at the tip of this nanoscopic iceberg that we've set foot on. And today, we're going to redefine yet another important part of seeing things, which is an image. So, when I mention an image or a photograph or a picture of something, like an elephant, then you immediately think of an elephant. Exactly an elephant, with no changes whatsoever. Now that's interesting. So you think that an image should be an exact representation of the object itself. That's cool. So now all I need to do is find a way to grab hold of an atom that's moving around at the speed of light and ask it to stay still for a minute while I grab its fancy picture. Seems rather impossible, isn't it? And yet scientists do manage to take pictures of atoms and molecules. So what are we doing wrong? Well, clearly, it's time for us to rethink the way we define an image. For instance, let's say I wanted an accurate image of a dog. Oh yeah, that's pretty accurate as it is. But the real question is, what about something that looks like this? Would you say that's accurate? Of course you would. And interestingly, you do see that it's different. You can tell that it's been inverted, but you still feel it's an accurate depiction of the dog. It's fair enough. But what about this one? Again, at first glance, you do see some sort of a modification, which in this case is a significant level of blur. But you do believe that beneath that layer of blur is the intact dog itself. Okay, that means it's time to pull out the big guns. So what do you think about these two images? And would you believe me if I told you that the first of these images is just as accurate a depiction of the dog as the previous images you saw? Of course you wouldn't. Even though I just literally told you that it is an image of the dog, you still wouldn't be convinced. But why not? What's that crucial difference between the previous images and this one that makes you so incredulous towards it? That is the fact that you don't know what's happened to the dog in this image. So you see, an image isn't just about being an exact representation of the object itself. No, it also tells you how the object has been transformed through the camera. That secret, unique code. And in the first couple of cases, you managed to crack that code. You figured out that the transformation of the object was a simple inversion in the first case and a simple blurring in the second case. In this case, you didn't figure out what the transformation was. So let me tell you, it has a complicated name to it. It's called a Fourier transformation. Yeah, it sounds fancy, and you can feel free to Google it, but at the end of the day, it is just another transformation to the object, like the previous ones. And that means this is just as accurate and informative an image as the previous ones. Oh, you're wondering what that last image is. It is a Fourier transform, but it's not the dog. It's actually a transform of the subscribe button to remind you to click on it and support my channel. So now that we've successfully redefined what an image means, you're probably wondering how on earth is this going to help me see atoms and molecules any better? Well, when we shoot beams of high energy radiation at molecules to take their image, these beams bounce off of the molecules and hit the screen to produce spots and stars and shadows of different patterns. And each one of those spots in the image has a story of its own. Now, it's the job of a structural biologist to decode every spot on the screen to finally figure out what a molecule looks like. And that is the second fundamental principle of structural biology. Now, in my upcoming videos, I plan to show you how different techniques generate images of different kinds and also show you how we decode all those images to finally view molecules. That's right, I'm going to be showing you real images of molecules in 3D. I'm looking forward to it, and I hope you are as well. Until next time, this is Varun from OK But Why. Stay safe, stay curious, and stay tuned for the next video.